Well, let's go. Okay. So area of a parallelogram, base times height, and height must be 90 degrees with the base. Okay, so now we're going to find the perimeter and the area. Start with this one. Start with perimeter. What is perimeter? Distance around, right? So parallelogram. So if I have this is 18 and that's 12, what else do I know?
That's 12 and that's 18.
Okay, that's 12 and that's 18. So how would I get the perimeter? Add them all up.
Multiply them up.
Add to them.
I just repeated what A.
So what is this?
80. No, 60.
It's 60 degrees, or 60, not degrees.
60 inches is our perimeter. Area, we need base times height.
So
What do we have right now? We have the
perimeter
and we have the base. Do we have the height?
No.
We got to get the height. But look, we are even given an angle measure of 60 degrees. Ooh. Oh, we can, but there's the beautiful triangles of 30, 60, 90, aren't there?
Yeah.
You're going to want to know these. Okay, so this side was x. What was the hypotenuse? 2x. And the other leg was x squared of 3. So, let's look. If we've got the hypotenuse here is 12, what would this little short side be? 6. So what would the height be? 6 squared of 3. You want to go through that again?
No.
I need to write that down.
Yeah, you probably want to write that down. So now the height is 6 squared of 3 and the base is 18, so we just have to multiply those two together. This is why you're going to need a calculator, because you guys don't know what the square root of 3 is exactly. So take the area would be 18 times 6 times the square root of 3. So what do you get when you multiply those together? Let's go to the 10th. Yep.
187.1
How do you label area?
inches.
Inches what?
Square.
Inches squared, or square inches.
Yeah, one stuff.
Sound okay?
Where is
Let's do the next one. Parallelogram, RSTU. Let's find the perimeter first.
40
So
on top.
80 plus.
Okay, so the parallelograms we know would be 40 up here and 24 there.
Plus 48.
128.
Okay, so add them. What'd you get?
128.
So the perimeter is 128 inches. Okay, now we want to find the area. Well, how are we going to find the height this time? It's a 45, 45, 90. Well, we better remember what those are. Yep, x square root of 2. So which one do we have there? We have the x squared root of 2. We have the hypotenuse. So what would we have to do with this number to get the height? Divide not by 2, divide by the square root of 2. So we would have to take 24 and divide it by the square root of 2. So our area would be 40
So,
times 24 divided by the square root of 2.
which is. Oh.
So 16.9 is absolutely correct for 24 divided by the square root of 2. Then we have to times that by 40 to get the area. Point what? 8, and we would say inches squared. Okay? So you got to remember your 30, 60, 90, and 45, 45, 90s. You don't have to write them exact how we were doing them, though. I mean, that is one benefit of this, is you don't have to figure out the exact values, but you are going to need to know how to find them to get them correct. Okay, so parallelograms.
Parallelogram.
What are those?
These.
Triangles.
What?
How do we find the area of a triangle? Oh, wait, what were we saying? Half what? That's a triangle right there. 1/2 base times height, area of a triangle. Trapezoid, I don't necessarily think you would have memorized, but for sure triangle and parallelogram you should have known. Trapezoid, you've done this before. Does anyone happen to remember it? Starts off with a half. Half of the height times base 1 plus base 2, or you are right, this used to be A and B. Back when you first learned trapezoid, one side was named A, the other side was named B. We name it B1 and B2 because we know that they're both bases, since we did a whole chapter on quadrilaterals. Rhombus. Actually, I think I should know this one. It's 1/2 D1 times D2, or D1 and D2 are the lengths of the diagonals.
I'm going D1.
But you gotta use both D1 and D2.
Looks like it did too.
Okay? Area of a circle, you guys should know. The circumference is 2 pi r, but what's the area?
Pi r squared?
Yeah, pi r squared. Area is pi r squared.
Pi r squared. Remember that.
You guys remember that one now?
I remember the rest of this.
Okay. So what we're going to do is we are going to find some areas of some other shapes now that aren't just parallelograms. Are we ready for those, or do we need a minute?
Wasn't a parallelogram, was it?
Right. So I said we're going to find areas of shapes that are not just parallelograms. None of those. Well, a rhombus is, but none of the others are.
Just check.
We ready?
Ready.
Okay, number 5. Find the area of this figure. What is that? It's not a trapezoid, no.
It's
not a square.
It's a polygon.
Quadrilateral.
It's 2 triangles. Everyone see the 2 triangles?
I see them.
I see 3.
I see 3 though.
Well, there are 3, but we don't have there's 1 we have the base and the height for of 16 and 21. And then our other one, right here, we have the base and the height for of 33 and 20.
Christmas colors.
Yeah, well, I mean, it was snowing, so
Oh, yeah.
Christmas has got to be coming again soon, right?
Yeah.
It's like next month.
Just completely skip spring and summer, back to Christmas?
Yeah, it's next month.
That's what I thought. Okay. So we have to find the area of each triangle, and then we're going to add them together. So how would we find the area of this triangle?
It's half times. Oh, what was it? Half times 20 times 30, isn't it?
Yep, half times 20 times 33. And then we want to add on the area of the other triangle, which would be what?
Half times 21. Half.
Yep, half times 16 times 21. The order that you put 16 and 21 in doesn't matter. The order that you put 20 and 33 in, it doesn't matter. So what would this end up being?
Where's the button? Oh, there it is.
Good, 498. Do we have
That's what I get.
a label?
Nope.
So what do we do? What do we label it as? Units squared. All right, 16. What type of shape is that?
It's a polygon.
It's a polygon. It is not.
It is 2 triangles.
This is another one of 2 triangles. Does everybody see the 2 triangles? Yeah, we got this one right here. Where's the other one?
Upside left.
Upside, right? Okay, so we want to find the area. So how would I find the area of the bottom triangle here?
Half times 60 times 15.
Yep.
Again.
Plus half times,
45 times, or 54 times 20.
yeah, 54 times 21.
I'm just like.
It equals 1,000.
Let's
Too
figure it out.
loud.
Oh, I just did that wrong. Yes, I did.
Anybody else have it? More than one
1,017
1017 label.
units.
Units squared.
Good. Everyone okay with that? This has been review so far, right?
Yes.
Now it
Okay. 7, what type of shape is this?
It's a round.
This is a rhombus. So a rhombus, we want to take the length of the two diagonals. Do we have either diagonal? No. What do we have?
Angle measure.
We have an angle measure
36.
of 30, 60, 90. Okay.
is 12.
So if 12 is the hypotenuse, so what would be the short leg? 6, and then what would be the longer leg? Okay, so now we need the length of the two diagonals. So what would the length of the diagonal with the 6 on be? Yep, because that other one would be 6, so the D1 would be like 12 here. What would be the length of our second diagonal? 3. 12 square root of 3. So once we have the length of the two diagonals, we can use the formula 1/2 D1 times D2. So 12 times 12 square root of 3. You'll definitely have to use your calculator for that.
Oh.
So what do we get for this area?
124.7.
Good, so area is 124.7 units squared. Sound okay?
No, that's a circle.
120.
All right, let's look at 8. What type of shape is 8? 8's a rhombus or parallelogram. But do we know the diagonals? Yeah, we're given them here. That's what makes it pretty easy. So what's the one of the diagonals here? This 10 and 10 would give me a diagonal of 20. What's the other diagonal? 40. So we have to take 20 times 40 and times it by a half. Don't use your calculator. Do this in your head. It should be simple. What is it? Good.
Wait, what?
Why is this a simple problem? Yep. Or, what's half of 20? 10 times 40 is 400. If you have nice numbers like that, you're going to be faster in your head than you are with your calculator.
Not in my head.
Should be. Let's see, we got to do some trapezoids and some circles then.
I like the circle.
9. What type of shape is that? It's a trapezoid.
With a triangle on the
No,
side.
that's not.
That just helps you find the height. That dashed triangle helps you find the height. Now, what are we missing from this one? The two bases. But we are given this. What's that? Yeah, that's the median. How did we find the median?
Don't you just divide it by 2?
Divide what by 2?
We should know your base.
Oh, I remember.
Oh.
Kind of remember some of this.
My notes.
Let's see, if this was base 1 and this was base 2, we added base 1 and base 2 and then we did what with it? We divided by 2 or took half of that.
Oh, we multiplied by 2 though.
That would be our median. Yeah, when we solved it, we would have had to have multiplied.
On the bottom and
And don't.
Okay, so 32 came from adding your two bases together and take half of it. So now let's think about the area of a trapezoid is 1/2 height times base 1 plus base 2.
60.
So what portion of this formula has already been solved for us?
Wait, what?
Base 1 and base 2
Base 1, base 2, and
are half.
the half. So we just need to take 32, because that's base 1 plus base 2 times a half, and multiply it by the height. Well, what's our height?
16.
So we just have to take 32 times 16 for this one.
It's 512.
Square.
So 512 units squared.
Why'd you put a 7?
Where's the 7?
Units 7.
Squared, there you go.
Units to the 7th
Which is a
floor.
really, really, really messy too. All right, so now let's do a more traditional trapezoid. More traditional, we don't have the median, we have the two bases. So how would I set this up?
So you'd add your 2 bases.
And divide by 2.
Okay, so we have 12 plus 24 for our two bases. What's the height?
28.
28. Okay, so it's half of 28 times 12 plus 24. Circles.
Oh, I know the answer.
You already got it?
5.
How do you find the area of a circle? If this says r of 5, so that means this is 5, my radius is 5. Yep, pi times 5 squared, so 25 times pi. What'd you get there, Tegan?
78.5.
78.5 on top of it. What do we do if we have the diameter of 22?
So it'd be 11.
So the radius here is 11.
69.1.
So pi times 11 squared. Yeah, 380.1.
I think it's that.
Well, 11 squared alone is 121.
Oh, I got it.
Okay. Is everyone okay with this?
Yeah. Got it.
Now, we didn't do some of the problems on here,
Of course.
but I don't know. We can take a look at the rectangle ones for sure. We'll look at these.
I hate these.
Ugh.
What are these problems? What are they all consisting of?
Ugly shapes.
They're not ugly. They're beautiful shapes. Beautiful.
In what way?
Number 3, what does it consist of? A bunch of what?
Numbers.
A bunch of rectangles. That's all it is, just a bunch of rectangles. So we want to split it up into rectangles. You can choose to split it horizontally or vertically, doesn't matter. Got to split it up into shapes that we can find. So do you guys want to split this up horizontally or vertically?
Vertically.
Vertically, so we'll just draw a line right there, draw a line right there. Now we find the area of each individual rectangle. So this one, it's a 3 by 8. So what would be the rectangle of a 3 by 8? 24. So this one has an area of 24. This is a 3 by, what would be the height?
5.
How do we get 5?
Because it's the 2 at the end.
Yep, the 3 and 2. So this is a 3 by 5.
50.
So 15.
Wait, so we're only doing like those little square parts?
Yep. Okay, so what's going to be the area of this one?
6 by 8.
It's a 6 by 2, so this is a 12.
Wait,
Then no, we add them up.
Then add them up.
so
Wait, 8 times 2. Oh, 8 plus 3.
50. 51.
51.
Oh, she was one number off. Well, that's all here.
And this one has a label, so feet squared.
How'd you get the 24 though?
This is a 3 by 8. 3 feet by 8 feet.
Can you just add all the numbers together?
No, you cannot add all the numbers together.
I don't know if it'd be the same.
Nope. That would give you the perimeter, not the area.
11, 11.
Okay, what would we do with 4 when we have like these two open spaces?
Add them and subtract them.
Yeah, you'd have to subtract the open spaces off. So what would be the whole space?
It would be 9. Oh, the whole.
The whole big rectangle.
18.
It's a 18 by a 30, so we'd have to do 18 times 30. Well, what's 18 times 30?
Big number.
540.
540.
Then you minus 8.
I thought you guessed.
Okay, so now we have to subtract off these two areas.
Oh, Oh, you gotta make the
So what's this area? This is a 9 by
9.
9, which would be what?
81.
81, so we have to subtract off 81, and then we have to subtract off
12.
a 9 by 12, which is what?
108.
108. So then we have to subtract off a 108.
351. 351.
Where did you learn how to count?
Square.
Is that okay?
Yes.
Yes?
Yes.
Okay, so what would we do with one like that?
Oh.
What is this? This is a square with what? With circles. So what would we have to do? Take the square and minus the...
Area equals length, or area requires square.
Yeah, so we would have to take the square here,
12 times 12.
which would be 12 times 12, and we would want to subtract off our circles, right?
How would we know our circles though?
Isn't the
Well.
diagonal circle 6?
This
Yeah.
one doesn't have numbers.
Okay, so this is 12. So we know it's 12 times 12 is 144, right?
Yeah.
Now halfway across, that would have to be 6, so that means the radius is 3. And how many circles do we have?
4.
4. Are they all going to have the same area?
Yes.
Okay, so we're going to subtract off 4 circles. And how do we find the area of each individual one? Pi times what?
So it would be
3
100.
squared.
Oh,
So then you'd multiply that by, oh, darn.
Could you also just do pi times 6?
113.1.
You cannot do pi times 6. You do pi times 9. And then times by 4.
So then it would equal 30.9.
113.1.
You got that? You already subtracted them, Andrea?
Yeah, just put that.
30.9. Yep. Does that make sense?
Could you also, if you did it with the 4 in front of it, just multiply what you get by 4?
Yeah, you could find the answer and multiply it by 4. Yep. Okay, so what would we do this one?
So,
This is a big circle, right? Minus 2 little circles. So how do we find the area of our big circle? What's our radius of the big circle?
8.
8. So we'd have to take pi times 8 squared, or 64, yep. Minus how many little circles do we have? 2. And what's the radius of each little one? 4. So we'd have to minus 2 little circles of pi times 4 squared, or pi times 16. What did you say, Andrea? 100 point what?
just on top of things today.
Is that okay?